Okay, spectrophotometric color calibration, one of the new tools that came with Serial 1.4, has a decent sized database list of all the sensors as well as filters that we use that allows us to more accurately color correct our images. Serial has built this database in a way that allows us to contribute to it as well. They're looking for help from the Serial community to even grow that database larger. That's what this video is going to be about. I'll show you guys how you can extract data from sensors and filters that are not yet in the database and then get them submitted up into Serial's repository so everybody can use them. So let's get to it. My name is Rich and you're watching Deep Space Astro. Okay, so let's start with how to add a new sensor into SPCC. The first thing that you need is a quantum efficiency graph, specifically the spectral sensitivity of the sensor that you want to extract the data from. Out of this entire process, this could be the step that proves to be the most difficult, especially with the camera sensors. Sony specifically doesn't appear to make these graphs available to the general public, so you need to go searching for them on camera manufacturer websites such as ZWO, Player One, etc. They generally will have these graphs. We're working with the IMX 415, which is the sensor that's used in the Dwarf 2 smart telescope. And in this case, this was a little bit difficult for me because not only does Sony not provide this chart, but Dwarf Lab, the makers of the Dwarf 2 smart telescope, didn't have it on their website either. So after doing some Googling around trying to find it with no luck, I actually used ChatGPT and asked it to do the search for me. And it found this graph, as you can see on a Cloudy Nights post. And you can see in the header of the image that it is from Sony with the IMX 415. So found what I needed. Like I said, this could be the challenging part, is just finding these graphs sometimes. But once you do have it, you want to save it to your hard drive. So I'm just going to right click on the image and say save as. And I have a folder just created, SPC, just to store the images and the other files that we're going to be creating for this whole process. So I'm just going to name the image IMX 415. So, and now we're ready to move to the step where we can actually extract the data needed from this chart. So I'll leave a link down in the description to this webpage here. This is from Serial's contributors documentation. And the first thing you need to do is utilize this website up in the first link here. So we'll click on that, and this website will allow us to load the image that we just downloaded and extract that data. So over on the right hand side, just click on load image and then choose files. And then we're going to browse over to the image that I just saved. This is an XY type of chart. So the 2D XY plot is what you want. Just click on align axis and then proceed. Now what we need to do first is specify 2 points for our X axis and then 2 points for our Y axis. And if you notice over here in the top right corner, as I'm moving my mouse around this graph, there's a zoomed in view of it. Utilize that as you're placing your points so you can make this as accurate as possible. So we're going to start with the first point for the X axis, which is down here in the bottom left. So I'm just going to line up my crosshairs as close to that corner as I can and click for X1. And then X2 is going to be over here on the bottom right. And once you place your point, you can use your keyboard up and down arrows to move the point around, watching your zoomed in view up in the top right corner of the browser just to get that nice and tight in the corner. So now we got the X coordinate set. We're going to do the same thing for the Y coordinates. So the Y in this particular case is going to sit right on top of X1. So we're just going to get that lined up, click for X1, and then top left corner here, same thing. There's Y2. Over on the right hand side, click complete. And then we have to specify the values for both the X and the Y axes. So you can see down the bottom, X1 starts at 400. So we're going to put 400 in this box. And then X2 is 1000. So 1000 for point 2. On the Y axis, it starts at 0. And it goes up to 1. In this particular instance, we don't need to make any changes to these fields. They're already set to 0 and 1. Once you have those 4 values in place, click OK. So you can see we have our data sets. First one says default data set. What I like to do is come down and say rename, and I'm going to rename that first one to red. And then I'm going to create 2 more data sets, one for our green channel, one for our blue channel. So to do so, click on data sets and then add data set. And then we're going to change the name to green and then click add data set one more time and we'll create one for the blue channel. So each one of these data sets, red, green, and blue, are going to contain the data from the graphs that you see in the chart. So I'm going to start with blue because the red channel is going to have an extra step involved in it. So we'll start with blue and work our way up to green and then to red. So click on the blue data set. And if you come over on the right-hand side, under color, foreground color, you can see it's already set to blue for us. So there's nothing I need to do here. If it's not, just click on the square and then select the color of the blue channel line that we see in here. And there's a couple different ways that you can extract this data, right? We'll start with the pen. So if I come over here to pen, and you can see there's a width you can change, you can actually come over and you can just highlight this blue line. And I just wanted to point it out because it's there. As long as you have everything that's blue in the highlighted area like this, you'll be able to extract the data. But you actually don't need to do this. The only time you'd really need to trace it out like this is if there were other blue lines that you did not want included in the data collection. I just wanted to point out so you know that it's there, and as well as to be able to show you the erase function. So if I come over to the erase tab over here on the right, I can say erase all and it takes that out. The easier way, since we only have one blue line in the graph, is to come over to the box tab and just simply draw a box around this graph. Now you want to be careful when you draw this. If I was to draw this and include the legend, it's going to try to extract data from this blue line that's up here, which is going to be completely erroneous and just mess up the data points. Same thing, you don't want to include any of the information that is in the X and the Y axes as far as the numbers that you see for the wavelengths and the relative responses. So just highlight the graph itself. We've got the foreground color set to blue. All you need to do is click the run button now. And you can see it put little red data points tracing our blue channel all the way across the graph. So just to show you real quick, if I was to come over and say view data, there's all my data. You can see 998, which is over here on the right-hand side of the graph. And if we go back up to the first one, 402, you can see that's where the first data point started. So we've got the blue done. We're going to do the same thing for the green. So we're going to come over and we're going to click on the green data set. We're going to change our foreground color to green. And then again, on the box tab, we're just going to draw a selection around our graph and click run. Now we have our data marked out for our green channel. Now, with the red channel, it's going to be a little bit different. We're going to use the same procedure, but you can see as it meets up with the blue channel, the rest of that channel, the rest of that line is hidden by the blue channel. So it's not going to be able to automatically extract that for us. So just one additional step. We're going to do the same thing we did previously. We're going to change the color to red. And we're going to come over to box and we're going to draw our selection around the whole graph and click run. And you can see it picked up a little bit of the red that was peeking out behind the blue, but it stopped after that. So to get the rest of this line, we're going to come up over here under manual extraction and we're going to click on add point. And we are just going to manually left mouse button click and add points down this line. And again, as you're laying the points down, you can also use your keyboard arrow keys to make minor adjustments to them, which is what I think we need to do right here with these ones that were laid down manually. So again, over on the right hand side, if I click adjust point, I can select any of these points. You can see it's red now, and when I select it, it turns green, and then just use my arrow keys to move it up more into where that red line exists. Same thing with this one. I'm just going to bump that up a little bit as well. The closer you can put these points on the lines, the more accurate the data point's going to be for you. And then same thing too, there's a delete data point button over here. So if you needed to delete one of these points, just select this button over on the right hand side and then click on any of these data points and it'll take the data point away for you. So now we've got our red data set, we've got our green data set, and we have our blue data set. Now we need to export all of this information out to a CSV file. So over on the left hand side, we're going to click on data sets and then just export all data. Then we're going to click on download CSV and just give it a name. Again, I'm going to call it IMX415 since that's the sensor that we're working with, and save. So if we jump over to this folder, there's our CSV file that we just extracted from the website. Before we can use this, we're going to have to open it up and delete these first two lines, red, green, and blue, and then our XY, XY, XY coordinates. Once you have those deleted, make sure you save the CSV file, and then you can go ahead and close it. So our next step, back over to the contributors website, is to create a JSON file from the CSV file that we just exported. So under device type, we have two options, whether it's a sensor that we're working on or a filter. We're doing a sensor right now. And then the sensor type, specify if it's mono or color. This one again is for the Dwarf 2, and I know that's a color one. And then we just need to fill in these fields. The first one is the manufacturer, so we have Sony. The model is the IMX415. And the data source URL. This is where you pulled your graph from. So in our case, we got it from Cloudy Nights. So we just want to copy the URL from here and place that in this field here. This lets everybody know, including the developers, when they review it, where you actually got your graph from. So when they review it, they know that it's accurate. It's the correct one that you used. Once you have those fields filled in, under CSV file, click on Choose File. And you want to grab the CSV file that we exported from the previous website. And then just click on Generate JSON. You can scroll down through it. This is what it built for us. Just use the download button and save it. You can see it use the name and the model number for the file name. So leave that as it is and just click Save. And then we want to come down to the validator. So we're going to click on Choose File and select the JSON file that was just generated for us. And we're going to click on Remove Duplicates. Sometimes when you're extracting data from these graphs, some of the data points are actually in duplicate of each other. So we want to remove those duplicates if that happens. And the validator will do that for you automatically. So just click on Remove Duplicates. If it finds any, you can see them here. Like in the red channel, it did find one duplicate. So it removed it for us. Green and blue look okay. There were no duplicates. So it did some cleanup for us. And then once that's done, you want to click on Display Data and it will actually plot it out for you. Click on the Save button. You can leave the name as default. Click on Save. Come back over to Remove Duplicates and download your cleaned file. You can see it just appends the word clean to the end of the file name. Click Save. Now I'm going to jump back over into my directory where I've been saving all of the images and the JSON files and everything that we've been working on. What I want to do is open up my original graph. We'll just use photos because it's quicker than Photoshop to open it up. And then I want to open up the one that we just downloaded from the validator. And this is just a quick visual check that your graph actually matches the graph that you downloaded. So let's resize these a little bit so we can see them side by side. Take a quick glance at it. Make sure that everything looks the same, right? So around 0.4, look at our blue curve here. And it appears everything does line up. There's the green and then the red. So make sure they look relatively similar to each other. And that's your indication that you've done everything correctly and you've extracted the data correctly. So our next step is going to be to submit the JSON file to Cyril to get it added into the database. Before we move to that step though, we want to do just a little bit of a rename here. The original JSON file that was created for us before we had it check for duplicates, I am just going to rename that to _org for original. And I'm doing that so I can take the one that it removed the duplicates from and name it Sony IMX415. That would be the preferred file name to submit the merge request up into the repository. So now we're ready to submit our new sensor into the repository. We do that using GitLab. Again, I'll leave the link in the description. You'll need to create an account for GitLab. Just come over and click on Get Free Trial. There's no credit card. There's no anything that you need to do. This is simply going to give you 60 days of full access, more than what you need, after which when it expires, you'll have access to their free tier forever, as it states right up here on the top here. So create yourself an account. And then once you have that account created, if we go back over to our validation page and right here under submitting your files, forking the repository, click on the Cyril SPCC database GitLab page. And then top right corner, you want to click the fork button to create a new fork. You can leave the project name at the default. Select your namespace. My case is my name. Project slug is fine. Description is optional. And you can leave the rest of the settings at their defaults and just click on fork project. And then once it's done, you can see that the project has been forked under your account. So if you look in the top right corner, you can see it says Rich Stevenson / Cyril SPCC database. And the next thing that we want to do is create a new branch. So we're going to click on the little plus button up top here. New branch. Branch name, I'm just going to call it add Sony IMX415. No spaces in the name, use underscores. It'll yell at you if you try to use spaces. Create from the main is fine, and then click create branch. So you can see my new branch is selected here. Now we want to add the new IMX415. So that would go into my OSC sensors folder. So we're going to click that to open it up. You'll see the list of everything that's already existing. Again, come up to the plus button. We're going to say upload file. And then we're going to browse out and we're going to grab our Sony IMX415 JSON file. Click on open. You can add to the commit message if you want. I generally do. So upload new file. And we just say sensor Again, IMX 415, and then click commit changes. Next step is to create the merge request. So you've added it to your branch, to your personal fork of the project, but it has not been submitted to Serial yet. You do that by clicking create merge request. There's a checklist you need to go through to make sure that you've done everything correctly here. So read through them each. The first one just says that you read the README file, how to collect your data. You made sure that there is no duplicates. And there's two options for each of these. The first one is referencing a Python script that you can actually run yourself. We use the online submission wizard, so we're gonna put an X next to that one. Same thing here. We verified that the data was correct. And again, we use a submission wizard for that. I'm gonna put an X that yes, we included the PNG file into this merge request. So to do that, we're gonna come down at the bottom of this template. We're gonna click the button up here to attach a file or an image. And we're gonna grab our graph that was generated by the submission wizard, and that'll attach it right there. And then at this point, you would click on create merge request. Now, as you can see at top here, it's already telling me a file with this name already exists. It's because I've already submitted this, so I'm just running through the process. So I'm not gonna click merge request, but once you do click create merge request, the process is done. It'll be submitted. One of the developers at Serial will review it, and once they approve the merge request and merge it into the repository, you'll get an email from GitLab saying that it's been approved. And then once you receive the email that everything has been merged into the repository, you go into Serial, you should be able to see the new sensor that you've added to the repository. Now, keep in mind, if you had Serial running, when you got the email that it's been approved, you will need to shut down and restart Serial. Sometimes you need to restart Serial twice for your local database to actually be updated, but the sensor will be there. So if you don't see it, restart Serial once, maybe even twice, and then check for it. So that's how you add a sensor, right? We did a color sensor. We came up into here and we specified color. If you were doing mono, same thing. You just select mono, same type of fields. And then when you hit choose file, obviously you're going to have a different graph here just for the mono. You're just going to have one line in your graph because it's not RGB, it's just mono. So same thing applies there. I do want to show you guys, we'll do a filter real quick and we'll take a look at the Optilong L Pro. So again, we'll click on load image, choose files, and load up the L Pro graph, align axes, and proceed. And just like we did with the camera sensor, we're going to set our X1 point, our X2 point, and then our Y1 point and our Y2 point. Click complete and then specify the values. So 350 for point 1, point 2 is 750, Y1 is 0, and Y2 is 100. Click OK. And we're going to do this the same way we did the sensor. What we're interested in with the filter graph is the red line here, which is showing us the light that it's allowing through, just like it shows over in the legend L Pro. So that's what we're going to go after here. So our foreground color, we're going to click on the box and we're going to select red and done, and our box tab, and we're going to draw a selection around. It's hard to see with this particular image because it's black, but I am drawing it. Once you let go of the left mouse button, you'll see the selection highlighted in yellow. Again, just click run, and you'll see all the data points are laid down. Now, with this particular image, you can see some of these data points fell outside of the actual red line that we're trying to collect the data from. So we're going to have to make sure we clean this up so we're extracting the correct data. To do that, come over to the right and click on Adjust Point. Select one of the points that are outside of the line that we're interested in, and then just use the arrow keys on your keyboard to place them directly on that line. So you can see we have just a few that this happened with. So we're just going to replace them. We'll move this one over just a little bit, maybe up. And then I actually want to put another point right here. So I'm going to come back over to the right and click on the add point button. And we'll drop one right there, and then just verify the rest of these are on the line. And again, where it gets narrow, it got confused and put the data points in the center. So again, adjust point, click on the point that you want to move and use the arrow keys, put it back on the line. And just use your best judgment. What I usually do is look at how the points, the spacing on the points that were laid automatically, and roughly get close when you're adding and moving these around. So I think we're good with the rest of these. Yep. Now with the sensor, because we had multiple data sets, we exported them all out into one CSV file and then modified the header of that CSV. You don't need to do that with a filter because we're not going for multiple channels. So we're just going to click on our view data for this one and then download CSV. We'll save it as L Pro CSV. And then if I was to open that just to show you, there is no header when we do it using the view data button. So there's nothing that you need to clean up as far as headers are concerned when you export the CSV data for a filter. So click close. We go back over to our contributor page, and just like we did with the sensor, we select the device type, except this time we're going to say filter, specify the manufacturer, so Optolong, this is the L Pro. Our data source, again, is where we got the graph from. This one came from Optolong itself, so we're going to copy that address, place it in here, choose our CSV file that we just extracted, create JSON, download it. I have a previous run here from when I was testing it, so we're just going to save it as the L Pro. Again, now we want to validate it, so we're going to choose the file, select the L Pro JSON, remove duplicates. You can see it found 12 duplicates, so we're going to download the clean file, save it, click our display data button to see our graph, and then save that as well, because that needs to be submitted with our merge request as well as compared to our original graph that we downloaded from Optolong. And that's it, we're done. So just go through the same process for uploading it to your forked repository. You don't need to fork it again if you're unaware. If you're not familiar with how Git works, you've already forked it once, so you forever have that fork in your account. You would just go and create a new branch like we did for the camera sensor, create your merge request, include this graph here that you saved off, and submit your merge request for approval. So there you go. We can all chip in now and help add to this database, help make the SPCC tool even better than it is. I want to take this time to say thanks to all my members here on YouTube and on buymeacoffee.com. Appreciate everybody's support. As always, thanks for your time. Thanks for watching. If you're not a subscriber, hit that subscribe button, light up the notifications bell so you never miss one of my videos. If you have any questions, leave in the comments below. We'll see you on the next video, and clear skies.